Hiya, I'm Carly from Kip Carlisle, and today we're looking at area and perimeter. Okay, so the first thing is children struggle to remember which one's which. So the easiest way that I've come up with to remember is that perimeter has the word rim in the middle of it. And rim means around the outside of something, so the rim of a glass. Okay, so perimeter, remind them rim round the outside. Okay, area is the squares on the inside. So then from that, we would then look at what the units of measurement are. So your area measurement always has a square sign on the end of it because it's counting how many little or big squares are in there. So square centimetres, square millimetres, square metres, that's what it's counting. So area is counting inside squares, so it has the squared on it. So your units would be metres squared, millimetres squared, centimetres squared, kilometres squared, whatever it is. Perimeter, you're measuring an actual distance. So you're still just measuring from one place to another. And so in that case, it's just millimetres, centimetres, metres, miles, kilometres, whatever it is. It's just a unit of measurement that is straight, so it doesn't have the square on it. I've put another couple of notes on here because when we're dealing with these sort of things, children need to understand what the point is, okay? So the reason that we might need it in practical real life terms to use area is to find out how much paint we need, because quite often on a tin of paint it might say covers up an area up to 9 metres squared, for example. So they need to know what area they're painting to find out whether they need more than one tin of paint. So area is going to be like things like painting, wallpaper, carpet, possibly wrapping something in paper. So those sort of things, they're going to require area. Perimeter is if you're looking at perhaps a fence, or sometimes they talk about wire, like wire, barbed wire, a wall, something that's going around the outside to contain something. So those are the practical uses of area and perimeter, because it's good to encourage them to think about how they're actually going to use these things. So I've drawn a few different pictures on here, and these have different formulas for different things. Now for perimeter, we'll start with that one. For all things where we're working out the perimeter, we're just going to add up all the way around the outside. So what I would always say when children are working with perimeter is, okay, we need to label all the sides, because any sides that aren't labelled, we're going to forget to add on. So on this one, they would label a 6, because that's going to be the same as that one, and a 5. And so then to find the perimeter, they're going to add them all up. 6 add 6 is 12, 5 add 5 is 10, add them together is 22. There's no units of measure written on these because that's my mistake. So it might say in the question, so they could refer back to the question, see if it mentions them in there. If it doesn't, you could just put units, okay? And for the sake of ease on here, I'm going to call them centimetres. So that's our perimeter. Same for this one here. Now, we would need all of the measurements. So for today, we'll pop that measurement on there. When it gets harder for children, they might be expected to calculate that using Pythagoras, but we'll leave that for today. So for that one, again, we just add up the measurements around the outside. 4 add 5 is 9, add 7 is 16. So our perimeter is 16, and I'm going to stick with centimetres. Okay, this one here. Now you'll see there's extra measurements on some of these, and we'll come to those in a minute, but for the sake of perimeter, it's round the outside. So we're going to do 5 add 8 is 13, 4 add 4 is 8, 13 add 8 is 21. And that's that one. This one here, again, we need around the outside. This is meant to be a parallelogram, not drawn with a ruler, naughty me. So 7, 5, this one would also be 7, and this one would also be 5, because for parallelograms, we've got 2 pairs of parallel sides, which is indicated with these little arrows. So if we add those up, 7 and 7 is 14, 5 and 5 is 10, add them together, perimeter 24. Now these are the ones where they get really stuck. So we've got to calculate some of the missing sides on this one. And this is a concept that children find a little bit tricky. But what I always do is I tell them to get a highlighter or a different coloured pen. Okay, so we've got a big long length of 11 centimetres there, which is the equivalent of this one plus this one plus this one, because it's basically been chopped up if we were to draw lines down. Okay, So that's what I would get them to work out. So if we've got 4 and 3 on the two that have been labelled, then we've got 7. Our total we know is 11, so what's left in the middle has to be 4. So that length there is 4. Okay, now this one's slightly more difficult again. We've got a 6 here, we've got a 1 here, and we need to know this one here. Now, this one here is part of this 9, isn't it? So if we can work out what this distance is and take that off the 9, we get that distance. So this distance here is the 6, take away that 1. So 6 take away 1 gives me 5 for this part here. So if that's 5, this is 9 take away 5, which is 4. Okay, so again, we don't need all of those lines, but that's just for illustration purposes. So now, if we look around our shape, we've got a label on every single side. Now, these are the ones where they, like I said, they trip up. So I would encourage them to tick off as they go. So 4, add 4 is 8. Add 4 is 12, 13, add 3, 16, add 6, 22, add 11, 33, add 9 is 42. So your perimeter for this shape is 42. And again, where it's a more complicated one, encourage them to do it again. I know children are very reluctant to do this, but it could have been a simple mistake. So if they go back round with a different colour, okay, so I'm going to go the other direction this time. So 9 add 11 is 20, 26, 27, 28, 29, 30, 34, add 4 is 38, 42. So I'm happy. Okay, done the perimeter for all of my shapes. Now I'm going on to area. Now for area, we usually have a formula, and they will need to learn them because they're not given them in the test unless they're sitting an IGCSE when they're older. They won't be given it in the SATs, and they won't be given it in a standard GCSE. So they would need to recognise these and remember them. Okay, easiest one is always the rectangle, and actually even easier than that, which is one I haven't drawn because I wanted to have a chat with you about it, is a square. Because this sometimes throws them as well. They'll say, there's a square that has sides 4 centimetres. What's its area? And they'll panic because they don't think they've got enough sides because they've only got 1. But with a square, we've got to remind them that squares have 4 sides that are all the same. So we do have 2 measurements. We've got that one. In fact, we've got them all if we wanted to. Okay, so for a square and a rectangle, the formula is length times width. Length is 6, width is 5, so 6 times 5 is 30 centimetres squared. Now, technically, you can put length times width on the square. Some people will just put W squared or L squared, because basically it's one side squared. But 4 squared is 16 centimetres squared. So that's how we're going to do our area on those types of shapes. So your first formula that they need to remember is length times width. Now, triangles are similar and children will always just do the same, but they need to remember that if you imagined your triangle was part of something and we extended it, it would actually be effectively half of a rectangle. So instead of just doing this times this, we have to then half it. So there's 2 ways people write this formula: half times base times height, or my preferred way is base times height divided by 2. So they've got to do the base times the height and then divide their answer by 2 to get it, because base times height would give me the whole rectangle. If I half it, I get the triangle. Either way, we end up with the same answer. We're doing 5 times 4 is 20 and halving it, which is 10. Okay. An extra thing to note on this one: triangles can be all kinds of shapes. Well, all kinds of ways round, I suppose. They're always a triangle, but there can be lots of different ways. So for example, it might look like that. So we're still on a right angled triangle there, so it wouldn't matter. We would just do our base times our height. However, we might also get something a bit like this. And so then we need to know this height. The height is always straight up and down, away from a flat base. So it's always perpendicular is what we call it, which means at a 90-degree angle to the base. So your base and your height are at 90-degree angles. So if they try to trick you and label this side, that is not the one you need to use. You must work out the height. Okay, same with something like that. We still need to know this height. Okay, but that is your second formula to learn. Now we can have whichever version. I recommend that one just because children struggle with the idea of what is a half times something. So go with this one because everybody can half something once they've got to this sort of stage. So that's our first two. Trapezium. Now a trapezium, basically, we want to know an average of these two lengths, because if we average them out, what we're basically doing is chopping off that bit and moving it up there, chopping off that bit and moving it up there, and we're making it into a rectangle. So we need to know the average length between these two, which just means we often call them letters actually, just to help people understand. So we've got A and B. So we're going to do A plus B divided by 2 to get the average of those two, and then times that by the distance between them. So not this slanty height, it has to be the perpendicular height. So times, on this one, it'd be 3, but we're going to put times H. Or some people even might write PH, so perpendicular height. Okay, so average times height. So for this one, the actual answer is going to be 8 to add 5. So we're adding them up, which is 13. Half of that, which gives us, I should have given us nicer numbers, but never mind. Half of 13 is 6.5, and times that by 3. 6.5 times 3, well 6 times 3 is 18, and a half times 3 is 1.5, so we've got 19.5 centimetres squared for that one. Okay, so that's our third formula that they can learn. Next one is our parallelogram. Again, nice and easy. This one really just links us right back to our first one if we think about it, because they're parallel. So if I chop off this triangle here and move it over here, it turns it into a rectangle. A rectangle which is measured 7 by 4. So what we do is just length times height. 7 times 4 on this one is 28 centimetres squared. So length times height for our parallelogram. And our last one is this guy over here. Now I have written my perimeter in the middle of him. I'm just going to move that to the outside, simply because when we're doing this one, because it's what we call a composite shape, we're going to need to do some extra bits on the inside of the shape. So I'm going to rub that off. Okay, so a composite shape just means it's a shape that's made up of a few other shapes. So we need to chop this up and work out the areas in little parts. Now there's two ways we could chop this. You could chop down there and do rectangle 1, rectangle 2, rectangle 3. Or on this one, we can chop this way. And we can have a big rectangle and 2 little ones. Entirely up to you. As I've now just done that one, let's do that one. So for this bit here, we need to figure out what the lengths are, and they are this 4 and this 4. So 4 times 4 for this little rectangle, which is actually a square because it's 4 and 4, just not very well drawn. 4 times 4 is 16. And I tend to label them inside, and then we're going to add them up at the end. This little guy over here is this 3 and this 1. 3 times 1, nice and easy, is 3. Now this is the bit that we need to do a little bit of working out. We talked about it before, but if this is 6 and this is 1, then this bit here is 5. So we've got 5 times 11, which is 55. Then we're going to add those all up. So 55, 3 and 16. 5 and 3 is 8. Add 6 is 14, carry the 1. 5, 6, 7. 74 centimetres squared. So that's all some different ways to do area and perimeter. Later on I am going to be covering how to do area and circumference of a circle, so that's going to be in a separate video. But if there's any questions or any comments, just pop them in below. Thanks!